Hey everybody, how's it going? So today we're going to solve LeetCode 103, binary tree zigzag level order traversal. So this question wants you to iterate through a binary tree and return the order of the nodes at each level in a zigzag manner. So for example, this is what the question wants us to do. So we're going to iterate through the binary tree in a zigzag manner, something like this. So, and so, kind of like that. And then return the order of the nodes in that manner, in the zigzag manner. So first we're going to heat 3, and then we're going to heat 20, 9, 15, and 7. So like this. All right, fair enough. So how do we solve this question? Well, there are many ways you could make this a lot more complicated, but we're not going to do any of that. What we're going to do is we're going to do a simple level order traversal in the tree, and then return the order of the nodes in the exact order they appear in the binary tree, and add those levels to an array list, and then we make a second pass through that array list, and then apply the zigzag order later. It's no shame to do 2 iterative passes in a question like this, especially when you don't want to make things complicated. So when we do the normal level order traversal, we're going to get the nodes 3, 9, 20, 3, 9, 20, 15, and 7. So this is what you get when you do the normal level order traversal. So first we go to the root node, we add it to its own level, and then we add its left and right children to the second level, that's 9 and 20, and then we go to 9, and then we go to 20, we add it to the array list, and then 9 doesn't have all the children nodes attached to it, but then 20 does, so we add the children of 20, left child and right child, to the third level, and then we have that as the normal level order traversal. So now that we have this, it's easier to make a zigzag using the array list data structure than using the binary tree data structure. So this is going to be the final answer. And how do we get to this answer is that we alternate the levels. We alternate the order of the levels while traversing this array list. So when we get to the first level, we know that the order is from left to right. So we add the order from left to right. And then we get to the second level, we know that the order is from right to left, so we add that order from right to left. We just reverse the order of the collection, and then this becomes 29, 20, and 9, and then we get to the third level. We know that the order is from left to right. So we keep alternating the order of the levels as we go through the array list, and that's it. That's how you solve this question. So now let's talk about the time and space complexity of this question. So for time complexity, we're going through every single node. And because of that, time complexity is going to be O of n. And for space complexity, we're storing an array list that's going to hold at most n elements in it, representing all the elements in the binary tree. So space complexity is O of n. So that's how you solve this question. Let's dive into the code. The first thing we want to do is declare an array list that's going to hold a list of levels. So I'm going to say list integer, let's call it answer, is equal to new array list. And then we want to check for edge cases. We just want to say if root is null. If this is the case, then what we can do is just return answer, because there's nothing in it. All right, so now that we have that, we're going to implement a normal level order traversal, and that means we will need a queue. So I'm going to create a queue, array to queue, and it's going to hold tree nodes, and let's just call it queue. I hope that's how you spell it. And that would be equal to new array to queue. Okay. And we're just going to add the root of the tree node, this one, to the queue. So we're just going to say queue, then add root. So I'm just going to declare another list of integer. List of integer that's going to hold the normal level order traversal. We might not need this, but let's see what happens. Let's just call it levels. So now we're going to iterate through the queue and then add the levels to the queue, because queue has a property of first in, first out. So the lower levels are going to be at the end of the queue, so we'll get to them last. So what we do is that while the queue is not empty, that means we still have elements in the queue. We can just get the size of the elements in this level. So let's say int size is equal to queue.size. Now that we have that, we're going to declare a list of integer that's going to represent this level. I'm just going to call it this level, new array list. and then we're going to iterate through all the elements in this level, in this queue. So we're going to say for int I is equal to 0, I is less than size. No, I is less than size. And then we can just do I++. So now we're iterating through all the elements in this level, and we're adding them to the list of integer that represents this level. So we can just say we get the current level, current tree node. So let's say tree node current is equal to q.remove. So after we remove it, it's not going to be there any longer, so we don't have to worry about it. And then we can just say this level that add current.value. Is it val or value? I think it's val. All right, cool. And now we just want to add the left and right children nodes of this current node into the queue. So now if we add it, it's going to be at the end of the queue. So we'll get to that later because we want to go level by level. But we don't want to add null nodes, so we just want to check if current.left is not equal to null. Then we add it to the queue. So queue.add current.left. And then we do the same thing for the right child node as well. So if current.right is not equal to null, and just queue.add current.right. All right, so that's it. We have one more thing to do. So after going through this loop and adding all the elements of this level into this array list of level, we want to add this array list into the levels array list. So we can just say levels that add this level. So I think that is it for the normal level order traversal. That should do it. And then after that, we want to iterate through all the levels and then alternate the order of the levels to mimic the zigzag pattern. So let's do that. So what I'm going to do is I'm going to declare a Boolean value that's going to represent the current order of the zigzag that we're going through. So for the very first level, we're going from left to right. So I'm going to call it left to right. That's going to be true for the first level. And then when we get to the second level, we alternate it. We go to the third level, we alternate it. And that's how we're going to do it. So let's say for int I is equal to 0, I is less than, I'm going to say levels.size, I++. So now we want to get the current level. So list of integer, this level is equal to levels.getI. And so now that we have the current level, we're going to determine whether or not it's going to go from left to right or from right to left. So if left to right, then we do nothing. We just add it to the final answer. So we just say add this level to final answer. You just say answer.add this level. And otherwise, if it's from right to left, then we want to reverse the order of this level to mimic the zigzag pattern. So we just say collections.reverse this level. If you want, you can write your own reverse function. It doesn't really matter if you do, you're going to get the same result. So if your interviewer wants you to write your own reverse function, you can simply do that with like 2 pointers and then switching elements as you go. But for these interviews, you have like 45 minutes or even less to answer a question, so don't sweat it. And then we can just say answer.add this level. So let's not forget to switch the order of the levels after we've added this level. So when we go to the next level, we want to go from right to left instead of left to right. So we want to set left to right. We want to flip it is equal to not left to right. So this is going to change it from true to false. And then in this other function, this is going to change it from false to true. Well, I think that is pretty much it. After that, when we're done with everything, we just want to return answer. Alrighty, let's run this and see what happens. All right, cool. It's accepted. Let's submit this. And it's successful. So I just noticed that you don't really need 2 lists of lists. You don't need 2 of them. Once you have this level, you can directly alternate the order of this level and then return the levels array list as the final answer instead of storing this answer. That's just a simple optimization that I noticed. Let's see how it works. To implement that, we're just going to comment this out because we don't need the answer anymore. If it's from left to right, it's already ordered from left to right, so we don't have to do anything. And then we reverse this level and we don't need the answer anymore. And then we change the order from left to right to left, and then we just return levels. And let's run this and see what happens. All right, cool. So that's it. We can get rid of this answer, and then we move this level up here and then return levels. So that's it. That's how you solve this question. If you like this type of content, please consider subscribing to the channel, comment down below if you have something to say, and share this video around the YouTube community. Smash the like button for the YouTube algorithm, and I'll see you in the next one. Bye-bye.